Jack Morris, recently graduated student at the Department of Computer Science at the University of Virginia. Welcome to the Data Exchange podcast.
Thanks. It's great to be here.
So I have Jack on the show because he and a few collaborators just published an interesting paper in an interesting library for adversarial robustness of NLP models. So for people listening to this podcast, probably many of you are familiar with adversarial attacks against computer vision and other machine learning models, but maybe less familiar that this is also happening in NLP. So, Jack, before we get into your library and your work, give us an idea of what exactly are these NLP attacks that are happening.
Yeah, so if you're familiar with the idea of adversarial examples in computer vision, I think that the end goal is the same, which is to develop some sort of modification to an input to the model, or at least fool the model into producing incorrect output. But at the core of it, I think the problems are very different. Like adversarial examples in computer vision are usually or quite often generated based on the gradient to the model. So trying to find a small change in the direction of, I guess, like maximum fool, like that will fool the model the most, which is very well defined in a continuous space like an image. On the other hand, in NLP, we don't have that sort of like mathematical like we don't have that kind of formulation that makes it a much easier problem. So you have to actually like find ways to search the space, usually not based on the gradient, because you still have to maintain some like linguistic properties a lot of the time. But so the end goal would be to create an input or a change to an input that fools an NLP model, which is a very general definition. I'll provide a few maybe more concrete examples. So one would be
So Jack, the idea here is that the machine is actually reading the text, as opposed to if you show an adversarial example to a human being, they may be able to pick it off immediately, right?
Absolutely.
But the machine has to wade through massive amounts of text during inference. So the idea is maybe you can sneak in some example. So here's a general question. So in computer vision, the attacks, I guess they could happen at training, at inference, but most of the things we read about are at the inference stage, right? So basically, you might have an attack on a self-driving car system, fooling it into doing something it's not supposed to do. So in NLP, are the attacks at training or inference?
Well, there is some work that has to do with, I think they call it like poisoning training data a lot of the time. Like, say you have control of a website and you know that some machine learning algorithm is going to be trained on text from the internet, including your website. You could find some ways to come up with text to put on your website that might like create some kind of backdoor in that machine learning model later. But the kinds of stuff that people usually talk about when they say like adversarial attacks and the types of things that our library TextAttack is designed to do are fooling the model at inference.
All right, so let's get to some examples. So what are some examples of fooling a model through inference?
Yeah, okay, so one example would be, I think Facebook and some other big tech companies have done these projects where they tried to train an NLP model that can detect whether a comment is toxic or not. So say, I don't know, you're trying to make some game that has like a chat box and there's going to be kids playing the game. So you don't want anyone to go on there and type things in that could be broadcast to a bunch of, minors. Then you would want to train a model that can detect at least a large portion of the inputs that are malicious and then filter them out. So the attacker in this case might want to like create an input that is toxic in some way and then fool the classifier into thinking that it's not. So there's different techniques for generating them, but you would like generate some string and then maybe make small changes to it so that the model somehow gets confused, and then you could put it in the chat. I think one other example would be, I think a good one to talk about would be that's a classification model. And then another very common type of model in machine learning are these text-to-text models, like translation models that take input from one language and output text with the same meaning in another language. Or there's some other interesting tasks like paraphrasing sentences or summarizing inputs. Those are all text-to-text. And maybe one attack would be like trying to produce text that has a summary that means something specific, or a translation that's actually not the correct translation but contains some meaning or something like that. Like say you were maliciously trying to, I don't know, create text that you knew would be translated and form some kind of like advertisement on the other end for users. That would be another example.
So actually, those are quite good examples in the sense that they're easy to relate to. Because, for example, a lot of companies will have situations where they have these text boxes where they have to really monitor what's going into these text boxes. So at a high level, Jack, is there a simple taxonomy that's useful for us to think through how the different types of attacks?
Yeah, let me think about that for a second. I think that the original attacks that might be a first category were all sort of kind of trying to port over ideas from the computer vision adversarial attack literature into NLP. So a lot of those did try to use the gradient. Like if you have an input with you could take the gradient with respect to one of maybe the words or tokens in the input and try and find the word that would change the meaning the most in terms of the model's like loss function. But those all kind of fail because the word that you change it to almost never means anything in context and definitely doesn't preserve the original meaning. But yeah, so that was a whole class of the original attacks, which are all using the gradient and like specific algorithms from computer vision and sort of like tweaking them a little bit so that they make sense in this discrete space of NLP. And then more recently, people are working on things that are instead of using the gradient, they try and make a bunch of queries to the model using words that actually do make sense in context. And then maybe like choosing one word that fools the model a little bit, and then taking that input, choosing another word to change, and then testing a bunch of different words. And then, yeah, so that's the more common approach now. And there's, a few different categories of things that you can tweak there. Like how do you do that search, and what kinds of words do you use to replace? And maybe even like what kind of function to use to determine that your new input still like makes sense. But I think most of the papers people have written in the last 2 or 3 years are proposing algorithms that do some version of that.
Yeah, it seems to me very a lot more challenging than computer vision, right? Because in computer vision, as you mentioned, your surface seems to be slightly more continuous, even though it's still discrete. So you may fiddle a few pixels, and it still looks like the original image, but it's already an adversarial attack. Whereas here, you're talking about words and letters, and at some level, they have to somewhat pass through some simple filters in order for them to even before they even get processed, right?
Yeah, you brought up words and letters. I would add that in my mental model of these attacks, there's 2 branches in that type of attack. One would be what I mentioned, which is trying to find words or phrase replacements that make sense in context. So like trying to produce another input that could have been written by a person and has the same meaning. So in NLP, we call that like preservation of semantics. That would be one type of attack. And then there's a bunch of other attacks that have a very different use case that are, instead of making word level changes, making character level changes. So there's some papers, one famous one is called Hot Flip, where they would take an input that the model deals with correctly and then change a few characters, as few as possible, to make the model's output wrong. And it turns out that you can actually replace, especially with shorter inputs, you can replace like maybe one or two characters in one or two words, and that would be enough to make many of even like these very effective state-of-the-art NLP models like confused and output the wrong prediction. So with the chat use case, that's definitely a big issue.
Yeah, and that's probably something that I mean, because a chatbot in some ways represents a company, so you can attack a company by attacking its chatbot.
Yeah, definitely. There was this famous case of Tay. Have you
Oh
heard
yeah,
of
yeah,
that?
yeah, 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 yeah,
Yeah,
yeah.
the Microsoft Twitter bot. Basically, people kept tweeting like these really horrible things at it, and it was designed to like learn on its training data. So when it would converse or people would tweet at it, it would basically like it would be iteratively retrained on the new tweets, and you know bad stuff, and the Microsoft chatbot started tweeting like racial slurs and a lot of bad words and stuff. And I think that whole project lasted for like 24 hours, and they took it down. It's never been
Yeah,
brought back.
yeah. I've talked to a couple of chatbot leaders recently, and I think one of the things
Cool.
they learned from that from earlier years of chatbots is now they have this notion of locality, in the sense that if I interact with a chatbot, it may pick up things locally in that conversation, but they're not going to propagate that to some sort of global model without some kind of human in the loop looking through looking through the transcript. So you can try to attack Tay. You may succeed, but only locally in your conversation with Tay.
So they retrain chatbots based on the local conversations for like a single person.
Or no, that's the worst case scenario, in the sense of even if they do some retraining, they're not going to do retrain globally without some QA process. Yeah.
That's very interesting. Yeah, and that's not even necessarily a breakthrough in NLP. It's more of like a systems design improvement. But
it's a recognition that that maybe for something mission critical, consumer facing like that, you should probably have a level of QA.
Yeah, that's a good lesson.
Yeah. All right, so let's go to your library, TextAttack. So let's talk about the origin story. So how did TextAttack come about?
Well, I described a few minutes ago that process of generating an adversarial attack on kind of like an abstract level, where you have this search and then you're making a bunch of typically word level substitutions to an input, and you have some function that determines which words to substitute, and then maybe you have some other functions that decide whether an input's acceptable or not, whether that's like based on whether it has valid grammar or whether it resembles the original input or whether it has the same meaning according to another model. Anyways, those are all sort of like knobs you can turn based on the same theoretical idea of an adversarial attack, which is like a search where you're making changes to an input, and with each change you have another set of functions that determine whether you think it's valid. That's a kind of like a high level framework for what for how these things work. And what we saw was there may be, I don't know, at least 20 different techniques proposed that use that same kind of idea, but they make small changes. So maybe instead of using synonyms from a thesaurus, they use synonyms that are proposed by another model, or instead of using a grammar checker, they use like what they call a semantic similarity model to make sure the two inputs are similar enough.
These are researchers and research groups who are proposing this.
Yes, yeah. These each one, when I say attack, would be like a new paper that's talking about a new method to generate adversarial examples for NLP models. And so there's a lot of overlap between these ideas, and a lot of the time, maybe even they're the same except for one or two tweaks. And so what we wanted to do was kind of like we separated those into components. So there's the search method, what we call the transformation, which is the thing that say substitutes synonyms or makes other changes to an input, the constraints, which decide whether an input is valid or not, like a grammar checker. And then finally, this idea of a goal function, which is like what determines how well you're fooling the model, whether it's, to induce new words in the output of a translation or to make a classifier think that a comment is not toxic. You can define a custom function. So maybe you want it to be at least 50% not toxic, or maybe you want it to be over 99%. But anyways, those are the four components of the search method: the transformation, the constraints, and the goal function. And we tried to implement all of the ones that we could find in the literature for each of those categories. And then for each paper/attack, there's kind of a file that runs that specific attack that builds it from the components. So place and then have scripts for like benchmarking them, comparing them on the same models, have some explanatory text for each thing, stuff like that.
So the immediate audience, based on how you're describing this, might be researchers who want to replicate an attack in another paper, right? So what's that the original audience?
Yeah, I think that was our main goal originally. And it makes it a lot easier to compare things that couldn't be compared before. So one of the things we did was write this one paper that's basically just benchmarking a lot of different common components and common scenarios with different models. So we can see which things perform better in ways that we couldn't before. And a really nice consequence that's arisen from this 4-component idea is that NLP data augmentation is basically just a set of transformations with constraints. So if you have like training data and it was really expensive to gather for some reason, people do this thing called data augmentation where they take each training input and make some changes to it and create a new training input. And since we already had these functions for, swapping synonyms with each other, paraphrasing inputs, maybe making a few character level changes, and then constraints, those are the transformations. And then we also have constraints, which are for determining if two inputs are, similar or if one is grammatically valid. We created the data augmentation module, which uses the transformations and constraints to do different types of data augmentation on NLP training data. So I think what we saw, which we didn't really expect, was that the data augmentation is a lot more popular for like the typical user than running the adversarial attacks.
Oh, interesting. So let me try to see if I understand this. So the data augmentation allows you to kind of expand your universe of labeled data by some simple transformation. So in many ways, this reminds me, Jack, of what they're doing in computer vision as well, where they're generating synthetic data. So it's definitely, but now it's text, and text has to pass the smell test, which is the reader. Someone has to read it, and it has to make sense. So it's a lot more challenging in some ways, right?
Yeah, absolutely. It's really challenging to make text that retains the meaning of the original text, let alone to avoid it being suspicious to the reader. Those are maybe two orthogonal problems, and they're both really hard. But from another perspective, it's a lot easier. Like if you have a picture of a dog and you want to generate a slightly different picture of the same dog, it really requires deep learning, like a lot of knowledge of what dogs look like and how to create realistic images. GANs are really good at this. But for text, there's a lot of experts on language, and we have a lot of tools and know-how for making changes to language based on what we know about it. I guess what I mean by that is like, lists of synonyms and grammatical rules that make it easy to maybe make some modifications to a sentence while knowing for sure that we haven't, for example, changed the grammar. So from that perspective, it's a maybe easier to do data augmentation on text.
So TextAttack, just like any other open source project, has the following evolution, right? So it starts with, let's build something for myself, and then let's build something for my friends, fellow researchers, and then who knows who's going to use it after that. So who's using it now, as far as you can tell?
I really like that
Has it
description.
has it escaped from the research community?
Yeah, we're working on that. It's definitely being used by some people researching adversarial attacks to run more benchmarks and to try and train more robust models by sort of like, training a model, running some attacks, retraining it, and doing that process over and over again. Those are definitely all sort of research problems. They're not very common, I'd say, for more like practical applications yet. On the other hand, there's some people that are using it in the corporate world. Like we have talked to a couple different like and another
So
I
so
don't know
uh,
what they're
so
working
so
on.
so repeat that because you broke up a little bit. You talked to a
Oh,
couple of what?
a couple of people from the business world, two different companies that are coming to mind. That one's working on a chatbot and another's working on this. It's also basically two different chatbot companies that have noticed that, say, if you create a chatbot where you say, "Hey, what's the weather today?" it might answer really well. But if you say, "How does the weather look today?" or make some small modifications to the sentence, but ask the same question, even for the most state of the art models, it's pretty hard to react appropriately to every single phrasing of the same sentence. So they're hoping to use TextAttack to like solve that problem a little better.
So Jack, is TextAttack modular in the following sense? Like, for example, as you say, I come across it and I realize, hey, I actually like this data augmentation component. That's the only thing I want to use. Is that possible?
Definitely. I think one of the reasons why people like it is because we tried to put a great deal of thought into making it, like you said, modular and reusable and preventing, like, we didn't want to dictate how people should use it. So if you just have a string that's, I don't know, I love watching movies, and you just want to generate a bunch of paraphrases, you can just import TextAttack, maybe 1 or 2 lines of code, and you can get a bunch of strings that have slight modifications from that input. So that's what I think, that I'd say that's probably our third use case after research and some corporate stuff, is people that want to do data augmentation and they want to use some of the components, especially people doing like Kaggle competitions and stuff like that. If you look on GitHub, I think that's what I've seen is probably the most popular use for it, at least so far.
So, what is the state of language support for TextAttack? So, there's English. So, what else?
Yeah, that's a really good question. That's our big, that's the thing that we're working on most right now. We have English and a few other Romance languages that are easily supported. We use WordNet pretty often to source synonyms, and there's some WordNet versions in like French, Italian, German, and so that sort of works out of the box. And like we were talking about, it's pretty modular. So French works, German works. We're trying to add more components for those languages, but by the end of the year, our goal is to make it. Well, let me step back for a second. I think like the one design decision that we made that I regret is we designed it very specifically to operate on the word level, which works great for English and a lot of other languages. But for example, for Korean,
Mandarin.
it's
Yeah.
not great to do like more token or character level substitutions. So we're working on like a refactor to hopefully support like splitting inputs differently based on characters for Chinese and Korean. So hopefully that'll be done by the end of the year, like 2020.
So TextAttack is an open source library, growing number of GitHub stars. And for our listeners, obviously, I will link to both the library and the paper. So Jack,
Thank you.
are there contributors now outside of the University of Virginia?
Yeah, I think still most of our main contributors are at the University of Virginia, but a few people have contributed a good amount from some other people or for some other areas of the research world. And then some random GitHub people have made some contributions. And then some other people have done like small things, fix typos, contribute to the documentation, stuff like that. So definitely, but we're still really looking for contributors. So if you're listening to this and it sounds interesting, go on GitHub. You can join our Slack channel, chat with us, chat with me, and we'd love to have your contributions.
So it also has an integration with Hugging Face, another tool that's popular with researchers. So what other libraries in the NLP ecosystem are you planning to integrate with?
That's a good question. So we've integrated, models from Hugging Face transformers, and more recently they've created this data sets package that in one line. And we reorganized our code to just use that.
Jack, you broke up. So start from I think recently they created
this data sets package that can help you load any NLP data set in like one line. So we reorganized our code to use that. So there's transformers and data sets. We support a bunch of models like PyTorch, TensorFlow, sklearn, Spacey, and then some other stuff that goes on behind the scenes, like part of speech tagging, named entity recognition. We use some other NLP packages as well. So some that come to mind are Flare, really good, really fast part of speech tagger, Stanza, maybe a couple others. Those are the main ones. We have a lot of dependencies, but it's good.
So let's say I'm a data scientist or a machine learning engineer in a company. I have a NLP project, and I want to use TextAttack maybe to either for data augmentation or just to make sure my NLP model is robust. So what are some easy ways to get started using TextAttack?
That's a great question. I think that the first and easiest thing is, unless you have training data on the order of like millions of samples, which is probably unlikely in most real world scenarios, you should try and use TextAttack to do data augmentation. Try out different transformations, try out different constraints as well, maybe different amounts of augmentation per example and different numbers of augmented examples per training example. You can play with all those hyperparameters and you'll definitely get at least a small increase in training accuracy. And then the next thing would be, if it were me personally, I would probably just run some of the adversarial attacks from TextAttack that seem pertinent to me and not try and do any specific retraining, but do some like qualitative analysis of the examples produced. So look at the things that your model mispredicts and think, okay, why do I think this isn't predicted right? What do I think we can do to make the model better, which is probably by collecting data in different scenarios. Those are the two things that I would start with.
So earlier you described some attacks for classification. So as you were speaking there, here's another classic NLP model and use case: entity recognition. So can you imagine any kind of attack or use of TextAttack for NER?
I'm trying to think of some practical ways that NER is used.
Yeah, NER would be extracting entities like company names, places, people from text, and then it's like a classic information extraction task, right? So then
Yeah.
you can run statistics and reports, right? So you can say the company Capital One was mentioned, is a trending topic or whatever, right? So
Right.
yeah.
Right. That's a good example. So maybe if you wanted some
You can
company or brand.
you can falsify a trend.
Yeah, definitely. Just try and figure out what types of text you have to write to uh, get a certain named entity extracted over and over again.
By the way, as I was describing this occurred to me. So what if I create a bot farm and then attach them to Twitter? Can TextAttack generate realistic enough tweets to make something trend?
That's a good question. Well, so you're saying you would have an initial tweet and make some modifications to it and tweet it over and over
Or
again?
I have like 10 tweets and then I point 20,000 bots here. Go nuts. Make this trend. Do you think it would be able to generate realistic enough tweets to?
Yeah. I think that if you had 10 tweets, it would be pretty difficult to get 20,000 different uh definitely, yeah. One thing that I'm excited about hopefully over the next year is to get some like really good paraphrase models integrated into TextAttack. So like specifically GPT-3 hopefully would be like a public API, and then we could see how well it can work on this problem and generate inputs with the same meaning. I bet GPT-3 could generate a lot of tweets.
So actually, so let's talk about what's next. What's next on the TextAttack roadmap? So you mentioned refactoring. What else? Language,
Yeah,
expanding the number of languages is another thing you mentioned, right?
that's exactly right. So our big action item right now is to do some refactoring behind the scenes, change some stuff around so that we can support languages like Chinese and then other languages that hopefully have cases that we haven't even thought of. And then working on some tools, like we have a lot of tools for English, but adding components for other languages. After that, I think the plan is to work a lot on data augmentation. Like I was saying, add some good paraphrase techniques and maybe add some metrics to take a list of augmentations and determine which ones might be the most useful for training and stuff like that. And then run some experiments to benchmark our data augmentation and show people what might be the most useful for them. Because right now we provide a lot of tools, but we don't know necessarily which ones might be the most effective for data augmentation. So that's what I'm really hoping in the next few months we can really improve. That seems like what people appreciate the most.
By the way, you mentioned GPT-3. I guess to clarify, GPT-3 is kind of a natural language generation. But when you talk about data augmentation, it's related, but it's not quite the same task in the following sense. I think what you mean by data augmentation is I want some realistic examples that look like my existing example. Whereas in the GPT-3 case, it's basically just generating realistic text, not necessarily related to not necessarily trying to do create similar text, right?
Mm-hmm. So GPT-3 is one of the most interesting things about it is that it has a pretty large kind of input buffer of text that it takes. So you can provide a few examples of a task. That's what they call few shot learning, I think.
Okay.
And then ask it to generate tasks or generate another output, and it'll try to solve the task. So, for example, you could put in maybe a toxic comment and then parentheses toxic, and then a non-toxic comment and parentheses non-toxic. Do maybe 4 or 5 of those, and then have another comment, and then ask it to predict the next few tokens, and it would probably be smart enough to tell you either toxic or non-toxic. That's how they test it on pretty much any NLP task. And so one thing that we could try would be, okay, take an input, here's a paraphrase of it, take another input, here's a paraphrase of it, and then give it the next input and ask it to paraphrase. But like you said, it has like a lot of different uses. So maybe another use would be that would be a transformation. You could also use it as a constraint. So two sentences, okay, these are valid, or the second is a valid adversarial example for the first. Another sentence, not a valid adversarial example, and sorry, pair, and then another pair of sentences, and it would tell you, yes, this is valid or no, and it could also be used as a constraint.
By the way, so TextAttack actually, in many ways, is kind of the first thing I've seen in for NLP, as far as I don't know how to describe it, but there's a general move, Jack, around the fact that people are recognizing that ML is different from traditional software engineering, right? Because now you have data and code, data and a model, so data and code. So then, how do we inject software engineering rigor into ML? So in this case, NLP. Well, one way to do that is to have more rigorous testing. So in many ways, maybe TextAttack is like a tool for unit testing NLP models.
Yeah, definitely. Are you familiar with this paper called Checklist?
Oh yeah, Marco. Yeah, I'm talking to him on Thursday.
Awesome.
I'm recording a podcast with him on Thursday. Yeah.
Perfect.
Yeah.
So he's the guy that was the idea behind the checklist paper, was to provide some unit test like tests for NLP models. And yeah, we actually just a few weeks ago finished implementing checklists as an attack and TextAttack.
Oh really?
Yeah.
Yeah. So TextAttack is really expanding. It sounds like.
Definitely, yeah. We're trying to keep up with what there's a lot of papers published every month usually that have these kinds of attacks proposed, and so we're trying to get as many of them as possible incorporated into TextAttack.
So by the way, so in closing, Jack, so we have these large language models based on deep learning. Should we be worried? Because we as a society and as users will start depending on these large models, and how robust are these models? I guess they're not exactly driving cars, so but still,
I don't know.
anywhere there's a model involved, we should, I think, be careful, right?
Absolutely. And what you see time and time again is problems that you would think would be solved by just deep learning, like you said, data and a model, end up being solved by deep learning and then some components around the deep learning model, like Alexa, for example, is basically a chatbot. You provide some input to Alexa, and Alexa provides a response and can maintain some sort of like conversational state. But Alexa, although it's based on deep learning, LSTMs, it's not just an LSTM. If it was an LSTM, you could make it say whatever you want. They have, I'm not sure what they do, but they have some sort of probably rule-based program running behind the scenes that determines whether an input is actually answerable by Alexa, and then whether its output is something that you want to produce. And that's how they prevent you from, I don't know, getting any really weird responses out of Alexa that they didn't anticipate.
Which is a good point, actually. So a lot of the models that we see in products are hybrid systems. And even if there's models, it might be an ensemble of models. But actually, more importantly, I think at this point, many of the systems might even be human in the loop systems.
Yeah, I'm sure.
Yeah. And with that, Thank you, Jack Morris, and good luck with TextAttack.
Thank you. It was really nice talking to you.